This is the third video on chapter 49, graphs of polar curves. And so our first example, we have r is cosine theta plus 1. And this is just the cosine. So first of all, we're going to do what we did with part B. Graph this with rectangular coordinates. This is just the cosine function shifted up 1 unit. So we can graph that fairly easily. We'll use this graph to sketch the polar curve. We see that when theta is 0, so this is our theta, this is our r. When theta is 0, r is 2. So we start right here. As theta increases from 0 to pi over 2, r decreases from 2 to 1. So we land right here. Then as theta increases from pi over 2 to pi, r decreases from 1 to 0. When theta increases from pi to 3 pi over 2, r increases from 0 to 1. So r goes from 0 up to 1. And then finally, when theta increases from 3 pi over 2 to 2 pi, r increases from 1 to 2. And so this is the graph we have. This is called a cardioid, I think for obvious reasons. Part 2, or I should say part D, we have cosine of theta divided by 2 plus 1. Now, this period is 4 pi. And so we graph this. Remember what dividing by 2 does. This is a horizontal stretch by a factor of 2. And then the plus 1 shifts the cosine, shifts the function up 1 unit. And so this is the graph of cosine of pi over 2 plus 1. And we'll use it to sketch our curve here. Now this has some similarities to the cardioid, but also some differences. Theta starts at 0. And when theta is 0, r is 2. As theta increases from 0 to pi, r decreases from 2 to 1. So as we get to pi, r is 1. Then theta increases from pi to 3 pi over 2. R decreases from 1 to 0. So it lands here. I'm going to sketch part of this now. So we start at 2, and theta, or r decreases from 2 to 1. And notice that it decreases over the whole interval from 0 to pi. And it lands at 1 here. So when it crosses here, it has to be greater than 1. From pi to 2 pi, r decreases from 1 to 0. But notice 3 pi over 2 is in between, and r is positive. So this is how we know that it doesn't just come to 0, that it does this little, that it crosses here and then comes back to 0. Because right here at 3 pi over 2, we're not going to calculate the exact value. We could, but it's greater than 0. From 2 pi to 3 pi, r goes from 0 to 1. So at 3 pi, which is back here, r goes to 1. And again, in between, right at 5 pi over 2, it's greater than 0. So we know that our curve does this. Because of this part right here. At 5 pi over 2, r is not 0. And then finally from 3 pi to 4 pi, r increases from 1 to 2. So that brings us back to here.